Diagnostics and Advanced Regression. It has three parts. First part, 6 minutes video. The important topics have been discussed. In the second part, main topics were again presented. Now, in this third part, we are actually going to see how these things can be worked on R. I have already written the commands in a Word file. One by one, I will copy these commands and paste it in RStudio. Then we will see the working. Now, these commands, actually, they are texts. If anybody needs it, they can contact, they can give the comments with their email ID, and I will send it to them. We are using a large file for all these workings. Earlier, I thought that I will be using inbuilt databases by R. And later on, we thought that we should create a database. And with that database, we are going to work on all these issues like model diagnostics and advanced regression. Let us start working. I will copy the commands and paste it in RStudio. I will wait so that you may be able to see the commands and then the results. We will load some of the results in a text file one by one in our main directory, R data. I have created this one folder, R data, and it is on the desktop, my desktop. You can also create a folder on your desktop by any name. And then we can set the working directory. When after setting the working directory, we need not have to file the path. Simply write down the file name and it will be saved in that data file. So we'll be saving a lot of files, even CSV files, which we are going to create in the programs. Please watch. Let me show you the first database file which we are going to use. It has columns: sales, advertising, price, competition, online rating, season index. Season index is low, medium, high, and competition level, whatever we are going to have it. So online rating is also given, price is given, advertisement is given. So we are going to actually see the sales as dependent variable. It will depend upon advertising, price, competition, online rating, season index. Now, let us see the R files. In the RStudio, first we are going to install a few packages and then we will initiate the libraries. The few text is already written in this. Now, in this case, first we are going to set the working directory. I'm going to set the working directory. You can also set the working directory by clicking on the session and then working directory. Then we'll see which working directory we are in. Get the working directory, we run it, and it is going to show me that I'm going to use R databases. Then we need the required packages: tidyverse, car, LM test, sandwich, GLMNet, GLMNet, correct, and matrix and splines. Now, these are the packages we need. And if there is anything new, that will also be installed in that. So we have written the text as new packages, required packages installed. So we are going to run it. The packages have been installed. Then we are going to set the libraries. Libraries as tidyverse, car, LM test, sandwich, GLMNet, caret, matrix, supply. These are the things. Now we are going to load our we have already loaded the libraries. Now we will load our packages, our database. So we will load our database. So I'm going to just clear it. And I'm just going to give the command. Now this is the basically our database is lying in the R data. So we have already set the directory. So large data regression data set .csv will be saved in the data path. And in the data path, from this data path, it will go to df data file, df. Now it is already there. We can see the heads, df heads. Df. If we run it, it will just show me a few rows, 6 rows it has shown me with this sales, advertising, price, competition, online rating, season index. I can have the glimpse of the data file, the df, summary of the df, and if there is any missing value. Now let us see, only run this part, see the glimpses. Now let us see, I am going to enlarge this pane and see the glimpses. It is highest, lowest. Rows are 2000, column is the 6. These are the columns with the high value. And then it is showing me the summary. Then it is telling me call sums. Is there anything, any column which are the missing values? It says nothing. It is 0. Counting is 0. So I'm going to minimize it and I'm going to clear this also. I'm going to clear this also. Step is to convert this processing. Our next step is that we have to create a model matrix, that is sales on advertising, price, competition, online rating, and season index. Data is our DF. We will have a model matrix, and Y will be DF sales, and we have named it X full and Y full. We will just run it. We will run these commands. These will run it. Okay. And we can see it also, what is X full, what is Y full, that we can see it also. Let us run the first regression, that is ordinary least square regression. OLS formula is sales, advertising, sales on advertising, price plus competition plus online rating plus season index. And OLS model is LM. LM is for regression, simple regression. OLS formula, which we have created above, comma data is equal to train. Only for train data, we are using the OLS. And it will summary the OLS. And then we will capture this summary OLS file in our File name will be ols summary.txt, which we will be seeing in our R database file. I will show you what are the results. Let us run this part. Now this is the file, already saved summary file has been given, but the summary has also been given here. Let us enlarge this one. Now this summary has already been given here. What is that summary? So summary is, this is the call for this residuals, minimum value, IQ, minimum value, first quartile, median, third quartile, maximum, that is all given. So now let us see this one. Intercept is 497.6801. Coefficient of advertising is 5.1642. And the T values have also been given. Price is minus 2.1169. Very good, this thing, because this is a negative sign. It means if price rises, sales will fall. And if price falls, sales will rise. And then we have got the competition. If competition is high, sales will be high. So you can say online rating is also high. So this will be there. And then seasonal index is low. That is a negative sign. And then season index medium. That is also a sign. So we can now see. And this one, the same thing which I showed you in the pane result window, the same thing has been copied here and it has been saved as OLS. Now, there is a database folder, that databases, and our large regression data CSV is this one, and this one is there. Where is that? Capture OLS summary. This is my text file, OLS summary. Text file is opening. To our folder, and in the folder we will see where they are all scattered. So this was our first one, that we can see the residual versus fitted line, if they are having any trend, or if they are having any movements, if they are showing any correlation with that, so then it will be shown. But in our case, it is not there. So this is our first diagnostics. Clear it, and I have pasted the new commands. Here we are going to run the first one. We are going to make the QQ plot of the residuals, QQ plot of the residuals. Then we are going to make the histogram of the residuals. And then we are going to show the scale location of PNG. Let us run this now. First, QQ plot. QQ plot. Let us see the next one, histogram of the residues, whether they are normally distributed or not. Run histogram and residual histogram. This is residual histogram. See the residual histogram, histogram of the residuals, perfectly normally distributed. See the curve, this is perfectly normally distributed. Okay, now seen the histograms, you can simply write the commands. You can simply write the commands. What is actually command? Hist, HIST, hist. OLS model, which you have already created, but now we are interested in residuals. OLS model, dollar residuals, and here you can make breaks 30 main residuals. This you can write up. Now let us see the scale location. We are going to make the scale location PNG, and it will be all OLS model fitted values plus square root of the absolute scale of the OLS model fitted value. So let us see now. Run. See this one model, what we have created, a residuals histogram we have already. Now we are going to run the three more tests. One is test of normality, which is actually the Shapiro test. So Shapiro test, it will simple Shapiro residuals, Shapiro dot test, sample OLS model, dollar residuals, minimum length OLS model, dollar residuals, 5,000 we have given it up to this. So Shapiro residuals will be there. That will be the normality test, and it will show me the Shapiro residuals. It will be captured and it will be shown in our main file. That is our folder, that scale location. So this is totally scattered, perfectly all right. So there is no problem with our model. There is no problem with our. Now, if you find any problem by histogram or by QQ plot or by fitted line with the residuals, then you can remove the outliers. You will have to find out the outliers by seeing the QQ plot and remove those outliers. Sometimes it happens, there are outliers. Suddenly something happens in the series. Say during COVID-19, it happened. Suddenly the series fell. So what we'll have to do? We will have to normalize it. Let us run the second test, Durbin-Watson test. See, Durbin-Watson test, the test value, the Durbin-Watson should be near 2. If it is near 2, then there is no autocorrelation. Durbin-Watson test is always used to see, Durbin-Watson test is always used to see whether there is any autocorrelation between the residuals. So, run it, and we will see now our folder, which is Durbin DW, Durbin-Watson text. This is our text file. And you can just copy this and put it in your thesis. Now Durban Watson here is 1.9758. So Durban Watson is 1.9758. P value is 0.3290. True autocorrelation is greater than zero, but alternate hypothesis. So P value is 0.32. It means it is less than 0.05. So that means there is no problem. There is no autocorrelation. And 1.9758 is also near 2. It means there is no autocorrelation. Let us run the third test, that is Bruce-Pagan test of heteroscedasticity. Heteroscedasticity, homoscedasticity, whether the variances are constant, whether the mean is constant and variances are constant. So that's why we are going to do it regression, Bruce-Pagan test. So this one is, we are going to run it, and the file will be saved as Bruce-Pagan text. Let us see what is the result here. This one is there. Now, here, again, BP is 3.1605, degree of freedom is 6, P value is 0.7884. So it means there is no problem. Had it been less than P value, had been less than this, then we could have said that there is a heteroscedasticity. Now it says it is homoscedasticity. Everything is normal. There are no problems with the database. We will clear this just to show you. And I'm going to clear this pane also. Okay. Degree of freedom is 1 or 2. Which shows us that OLS RMSE is 96.76. Mean absolute error 77 point this, R square is 0.79, AIC is this, BIC is this. Number 9, where we are going to have the rich, lasso, and elastic net, GLB, MNet. And here we are going to get the X trains and Y trains. Only training data will be with the X rich, and then we will calculate the best lambda rich model. Then we are going to calculate the lassos and elastic net with the formula CVN list, and it will calculate with the loop. Let us run it. And it will save all the files in our text. Okay. Now all the files have been saved in the text as coefficient of ridge, coefficients of lasso model, coefficients of init CSV. And we are going to run this program, which has been named as number 10. And we are using only the train data. And in the train data, this file will be saved as logit underscore AUC polynomial, regression and sublines. Now this will be polymodel and it will be linear model, and then it will capture the output as polynomial and spline. So it has been saved there. Let us see this polyspline performance CSV. Polyspline, this one is polyspline performance CSV. So here also it is OLS. It is giving us OLS, RMSE, and poly 2 and spline. These are all numbers are given. I'm going to put that file in a description box. If it is not available, then you can request in the comments box. I will forward this file to you, and then you can perform all the tests. So this is 1/12th number where you are going to run it. And let us see the file name. This file is performance summary CSV. Performance summary CSV. Now this one, the performance summary CSV for all RMSE, MAE, for OLS, for Ridge, for Lasso, for elastic net and polynomial. Now in polynomial, and we are not getting MAE and R squared test, we are getting only RMSE. In the test prediction comparison CSV file, see, all the test predictions have been given. See, prediction by OLS, prediction by Ridge, prediction by Lasso, and prediction by INET. This has been given. See, in all these three have been given. This is the prediction by OLS. This is the prediction by OLS. So prediction by OLS, prediction by Ridge, prediction by Lasso, prediction by, for each observation of the trained data. Each prediction for the trained data has been given, we give suggestions to ourselves. Now, if we inspect, and then it will tell us it will go to the next step, TXT, we will run it. It will tell us, it will give us the suggestions and run it. And we will see the next step. What is the next step? This one, the next step. It suggests us inspect top influential observation.csv if present and decide whether to remove or transform. Now, if heteroscedasticity is detected by Brewster's Pagan significant test, consider weighted least squares or robust standard errors. If VIF is high, consider regularization, Ridge or Lasso or PC. Use K-fold CV for final model selection and hypermeter tuning. Consider interactions if domain knowledge suggests them. For example, advertising season index. So these are the final suggestions which are common for all the models. Thank you for watching. I will try that you should get this all 13 models. If you are not able to get it in the description, please comment and I will send you this file. Then you can work on CS. You can work on ASK. Thank you.
Difficult. Don't worry. Get the file and practice on R. It will be very easy.